Hi guys, in this video we are going to wrap up our transformation of the graph series. First we are going to be given a function. It's not one of the 6 basic functions. We are going to be asked how is it related to one of the graphs of the 6 basic functions, and then we're asked to sketch it by hand. Then we're going to be given the graph of something, and then we're going to be asked to give the equation. And for the grand finale, we are going to be given the graph of a function. It's not going to be one of the 6 basic functions, so we can just easily put it in our calculator, and then we're going to ask to apply a transformation. So this will be a true test. Awesome. So let me just go ahead, grab my pencil, and then we're going to freehand this. Okay guys, I found my pencil. Well, it's actually my pen because it's easier to project. So we are given a function. It's not one of the basic functions, but we are asked to indicate how it's related to the graph of one of the basic functions, and then we're gonna sketch it by hand. Okay, so this is how I do it. I look at the x, and then I notice what's next to it, and I'm gonna temporarily ignore it. So that way it kind of reminds me of y equals x cubed, and this constant term has to go. Okay, so if I keep my cool and squinch really hard, that kind of reminds me of the cubic function. So we have a y equals x cubed, and if I remember correctly, this kind of reminds me of the Egyptian pose. Well, at least for me it does. Okay, so we're gonna tell the reader from the graph of y equals x cubed, we're gonna do this, then do this, and then do that. Okay, so now the question is, should we tell the reader that we're going to shift vertically or horizontal? What to do? So many options. So when it comes to applying the order of transformation, we have to just remember order of operations. So order of operations, we look at grouping symbols. So inside this grouping symbol, we look at things that are next to the x. So we're gonna anything related to the x in terms of shifting, it's gonna be horizontal. And then if it's being multiplied by a negative, well, we're gonna have a reflection. And if we have a number other than 1, we're going to have horizontal stretch or shrink. So coming back to order of operations, we have grouping symbols. So we attack the grouping symbols first, and then we have exponents for the transformation that's ignored. So grouping symbols, exponents, then multiplication or division. So what we are going to see what we're multiplying the grouping symbol by, so that will be our vertical stretch or shrink, and if we have a negative, it will be a reflection. And then coming back to order of operations, grouping symbols, exponents, multiply or divide, and finally we add or subtract. So whatever that constant term is, that will give us some kind of vertical shift. So let's go to attack mode. So looking at the grouping symbol, we have x minus a number, and then I have to remind myself that horizontal shifts are of the form f of x minus c. So it's been a long time since day 1, well, since the beginning of this unit. If c is positive, then we're going to shift so many units to the right, and if c is negative, then we're going to shift so many units to the left. In terms of identifying c is the number that follows the subtraction sign. So the number that follows the subtraction sign for this problem is 2. So for that reason, the value of c is 2. So we're going to tell the reader, hey reader, that's an arrow by the way, hey reader, from the cubic function or from the graph of y equals 2, we're going to shift 2 units to the right, and then let me go ahead and write that out, because this is not a verbal quiz. So from the graph of y equals x cubed, we have said we're going to shift 2 units to the right. So we're going to write shift to right. Then okay, we have no negatives inside or multiplication inside, so we're gonna look outside the grouping symbols. There's nothing outside, so there's not gonna be any stretching or shrinking vertically, and then we follow the constant term. So in this case, because 3 is negative, we're gonna shift 3 units down. Okay, so from the graph of y equals x cubed, we're gonna shift 2 right, then shift 3 down. Cool. So that is the first part. We have to indicate how this bad boy relates to the graph of one of the basic functions, and we just did. So we told the reader from this graph, shift 2 right, then shift 3 down. So then we're gonna go ahead and sketch it out. Let's go ahead, let me do a thinking area right here. So the graph of y equals x cubed looks something like this. I'm going to go ahead and identify this point. So at this point, what is it? Y equals x cubed. If x equals 0, y equals 0 cubed or 0. So I'm going to take this point, I'm going to anchor it, and then apply these commands. So we're going to go 2 right. So we have 1, 2. And then we're going to shift 3 down. 1, 2, 3. I believe that's negative 3. So this point that was 0, 0, after we go 2 right and 3 down, that's going to be 2, negative 3. And then it'll be something like this. Yeah, sorry, bad placement for this table. It's okay. Good thing that this is our thinking area. We're going to submit it right here. So we go 2 right, 3 down, and that was the point given by 2, negative 3. Let's go ahead, transpose this to our solution area. So 2 right and then 3 down. And then at this point, I'm going to go ahead and do a table of values to locate 2 more points. Ideally, one to the left of x equals 2 and one to the right of x equals 2. So for our table of values, you know, y equals cube of x minus 2 less 3. When x is 2, according to our commands, y should equal negative 3. But let's go ahead and verify that. I'm going to go ahead, with your permission, type in this function. Cool. Can you see it? Hope so. Okay. So we have y equals x minus 2 raised to the 3rd power. And then we're going to subtract 3 from it. And then we're going to go to the table of values. So we had, from our commands, we have that when x equals 2, y should equal negative 3. And looks like we did it correctly. So I would like to pick an x value to the left of 2. So we'll pick 1. So when x is 1, you can do it by hand. But for the purpose of time, we'll punch it in. When x equals 1, y is negative 4. So let's go ahead, locate that. 1 to the right, 4 down. And let's go ahead, pick an x value to the right of x equals 2. So we'll pick 3. When x is 3, that will give us y equals negative 2. Now, with tired eyes, I really want to connect these 3 points to make a straight line. But we already have a sense of what it should look like. So we're going to try to do our best to do our Egyptian pose, going to 2, negative 3. Hopefully I do it right. And if not, it's okay if I'm a little bit off. Alright, I try my best and I think that's okay. Cool. So for this fun problem, we have 2 sets of exercises. That is our first one. Let me go ahead, turn to the next one. Okay, so for problem B, same speech. We are given a function. It's not a basic function. It's not one of the basic functions, and we are asked to indicate how it relates to the graph of one of the basic functions, and then we are asked to sketch it or graph it by hand. So I'm going to locate the x. It's inside a grouping symbol. The radical is also a grouping symbol. I'm going to cover up the plus 3. I'm going to cover that plus 1, and if I had an extra finger, yeah, I have 10 total. I'm going to cover up the negative sign. So once again, if I squint really hard, this kind of looks like y equals square root of x. Okay, so this is going to come off from y equals square root of x. So I'm going to tell a reader, okay, reader, this is how we're going to graph it. From the graph of y equals square root of x, we're going to do this, then we're going to do this, then we're going to do that. But let's go ahead delineate that one step at a time. So order of operations, we have grouping symbols. We're doing something to the x, so we are going to have a horizontal shift. But bear in mind, horizontal shifts are given of the form x minus c. Well, I should say f of x minus c. So I need to know what are we subtracting from the x, not what are we adding to the x. So we're going to force a subtraction. So we are going to change the addition sign to a subtraction sign. And if we're going to change the operation, then we're going to have to change that second entry. So 3 is positive. Well, just kidding. We're going to make it negative. Okay. So we're not changing the function itself. We're rewriting it. when we say changing, we're changing the meaning. When we rewrite it, it looks differently, but it still has the same meaning. So subtracting -3 is the same as adding 3. So now the question is, okay, what are we subtracting the x by? That will give us the value of c. So in this case, we're subtracting the x by -3. So that means that since c is -3, then we're gonna shift 3 units to the left. We're gonna pretend you can read my writing. So let's go ahead, start writing our description. So from the graph of y equals square root of x, we're gonna shift 3 left. Shift 3 left. Then what are we gonna do? So we're outside the grouping symbol and we have a negative sign. So we're changing the function value, which is being applied to the y. So it's kind of like saying we're going from positive y to negative y. So to go from positive y to negative y, we're gonna reflect about this axis. So we're gonna say shift 3 left, then reflect about the x-axis. Cool. That deals with the negative. So order of operations, grouping symbols, and then like we multiply or divide, and then we add or subtract. So since we have a +1, we're gonna shift 1 unit up. So then shift 1 up. Okay, so let me go ahead and box it. Let me go ahead, do some quick sketches. Okay, so where should I do it? So many decisions. Okay, I'm gonna go ahead, do it right here. Okay, so I didn't do the quick sketch before of the square root of x because I was a little nervous, but it goes something like this. Okay, so in this case, the domain is gonna be from 0 and up. So we are at 0. To be more specific, it's gonna be 0, 0. Why? Because it comes from math. If x is 0, square root of 0 is 0, and then I'm gonna do my quick sketch. Okay, let me go ahead let me go ahead, highlight that for fake extra credit. Okay, and then we're gonna shift 3 left. So I'm at 0, 0. We're gonna go 3 left. So 1, 2, 3. So that will give us 3, 0. And I'll take a different color this time. Okay, pink. Yeah, okay. Pretend you can see that. Yeah, this didn't work so well. Okay, I should have practiced before making this video, but you get the drift. Okay, so we shift 3 left, and then we're gonna reflect about the x-axis. So if I took this pretty piece and did a mirror image, or I took a selfie on the other side, it should look like this. Let me go ahead, take another marker. Yeah, I didn't quite take the selfie. Sorry, that's due to human error. If I was good at math, I would make it look exactly like this part. Okay, so we're gonna reflect about the x-axis, and that point that I anchored, we went 3 to the left. I was at 3, 0. If we reflect, we're still at 3, 0, and then we're gonna shift 1 unit up. So if I shift 1 unit up, that should bring me to 3, 1. And then like that. I ran out of highlighters, so you have to use your imagination. Okay, so we're just gonna go ahead, take this and shift it over. So let's go ahead, do our XY table. So when x is 3, according to our commands, y should equal 1. But I want to just punch it in just to be on the safe side. And to save time, we're just gonna use our calculator. Okay, so we have y equals, where do I not have the glare? Y equals negative square root of x plus 3. Get out of the grouping symbol, or radical, in this case radical, and then we're going to add 1. Then we're going to go to table. So second table, when x is 3, our command said that y equals 1. If it doesn't equal 1, I'm going to cry. Okay, what did I do? I think I punched it in wrong. It's because yeah, human error. You already caught that, but I didn't. It's okay, it's okay. But see, good thing we checked it. So you know what I meant. Okay, so we're not gonna start this video from the beginning. Okay, so let's go ahead, scratch that. Okay, so when x is -3, we have y equals 1. So good thing that we already knew where we're supposed to be, but it would have been nice if I labeled it correctly. Okay, so we're at -3, 1. So we have -3, 1. And we already did a quick sketch, but we're finding ordered pair solutions. So let me go ahead and put it in yellow. I think I found yellow. Okay. So in this case, the graph of y equals -√x plus 1 is given by the yellow graph, if you can read it. So if I could just take this and transpose it over here, it would be nice, but nice doesn't happen. So in this case, I'm not going to pick values to the left. That's going to be outside the domain. We're going to pick values to the right. So it'll be -2, -1, 0, and so forth. So if x is -2, let's go ahead, pick -2. Y is 0. So -2, 0. Let's pick -1. I'll pick a handful. X equals -1. Oh, I have no time to round. If x is 0, I don't have time to round. If x is 1, oh, that's a nice number. So if x is 1, that will give us -1. So I'm at 1, -1. And we can continue to punch it in. If x equals 2, oh, that's not an integer. How about 3? No. How about 4? No. How about 5? No. How about 6? Yeah, I should have known that, because 6 plus 3 is 9, and we could square root of 9. Well, we could square root any number, but it'll give us an integer. Okay, if x equals 6, that will give us -2. And I don't even have a space to locate x equals 6, so I should have just stopped at my first 3 points. Sorry, I got a little excited. Okay, so we're just going to use these 3 points. Cool. And I think it looks just like we did right here. Okay, so did we answer all the questions? So the first part, we were asked to indicate how this bad boy relates to the graph of one of the basic functions, which we did, and then we're asked to sketch it by hand. Fantastic. Alright, so for this video, we were going to do 3 sets of fun problems. We have 1 set down, 2 more to go. So it says the directions. Yeah, always read the directions. So it says the following graphs are transformations of the parent graphs. And the question is, we are asked to write the equation of each graph. Oh, good. I like writing equations because graphing is not my forte. So this graph right here kind of reminds me of the square root function. So it's something like this. Okay, so maybe I made this a little too high or whatever, but it's just so I have a sense. I just know that we're at 0, 0, because when x is 0, value of y equals square root of 0 or 0. So then what's going on? So let me go ahead and highlight the graph from the problem. Because with tired eyes, I don't even know which one did I start with. Okay, so in this case, I guess we took the graph of the parent function and then just shifted down so many units. Okay, so we shifted down 1 or 2 units. So we shift 2 down. So the equation, we have y equals square root of x. So that is the equation of one of the basic functions. And what did we do to it? We just shifted down 2 units. So let's go ahead, subtract 2. Fantastic. Moving forward with problem B. So we have this bad boy. Let's go ahead and highlight it, just because you know I'm going to tag up this graph area, and it would be nice if I see what's the problem that we deal with. Okay, so this comes off the graph of the square function. You know, we have y equals x squared. So when x is 0, y is also 0. So we're right here. Yeah, pretend this is really nice. And then what's going on? We are going to go to the right, and then we're going to go down. So we're going to go to right. Cool. So remember, horizontal shifts are of the form x minus a number. So because we went to right, then c equals 2. So we're going to take that x, and then we went to right, x minus a number, so it'll be x minus 2. And then we're going to drop down so many units, 1, 2, 3, 4. So if my eyes didn't fail me, we're going to drop down 4, so 4 down. So we are gonna take, yeah, it would be nice if I had an equal sign. That will give us, before we had square of x minus 2, we shifted down 4 units. That will give us square of x minus 2 minus 4. Fantastic. So we have one more fun problem. Alright, so for the third problem for the set of exercises, so this kind of looks like an upside down V, which means that this graph stems off the absolute value function, okay, which is like this. And that is upside down, so we're going to have a reflection about the horizontal axis or the x-axis. So let me go ahead highlight this, because I'm going to tag it up, and it would be nice if I was able to see the original function. So when x is 0, y equals absolute value of 0. So we're at 0, 0. I'm going to do a quick sketch. And then what's going on? We want to go from x equals 0 to x equals negative 1. So we're going to shift 1 unit to the left. So shift 1 left. So that will give us c equals negative 1. So remember, horizontal shifts are of the form f of x minus c. So we're going to take that x and subtract from it the value of c, which is negative 1. So we have y equals absolute value of x minus negative 1. Or it would just be nicer if we put x plus 1. Cool. So we went 1 to the left. Cool. And then we have a V going like this, but we need an upside down V. So we're going to reflect it about the horizontal axis or the x-axis. Let's go ahead, put a negative sign in front. Kind of like saying, how do we go from positive y to negative y? Okay, so we'll reflect, then reflect about the x-axis. Cool. So I lost my place where I'm at, so I think this is why we're not supposed to write in this area, but it helps. Okay, so now we have an upside down V. We just need to move it up. So then we're gonna shift. We are at negative 1, 0, so we just need to shift to 1, 2, 3 units. Then shift 3 up. Okay, so vertical shift, then we're gonna go ahead, add 3 to the function or to the value of y. Cool. And if you wanted to check, it's something that I failed to put. Let's go ahead, I wasn't planning on doing this. I didn't have my calculator near me. Let's go ahead, graph what we have. So we have y equals negative absolute value. I don't use this a lot, so I just found it. Absolute value of x plus 1. And then we add 3 to it. So supposedly we told the reader that this is the function for the graph that was provided. So let's go ahead and graph it. And we should get an upside down V. And that kind of looks like the book problem, so we nailed it. Fantastic. So I think we have 3 short problems and then we're done. Alright, so for the grand finale and for the final video in the series, so we are given a function. As you can see, this is not the graph of one of the basic functions, so it's not as easy as just punch it into the calculator. We have to really pay attention. So this is the graph of a function given by g of x. And the case, if you're wondering what happened to f of x, I got tired of it, so I just changed the name. Okay, so we have a function. The domain is not all real numbers. It goes from x equals negative 2 to positive 2. So the domain is from negative 2 to positive 2, where both negative 2 and 2 are included. Cool. So we are asked to graph g of x plus 2. So in this case, we're changing the x. So we're going to have some horizontal shifting. So remember, horizontal shifts are given of the 4 x minus c. I guess I should put g of x minus c to avoid the confusion. Horizontal shifts are given by the 4 g of x minus c. So I need to know what are we subtracting the x by. As you can see, this is not a subtraction problem, so we're going to go ahead, switch it up and write it as x minus negative 2. Now that we have a subtraction sign or a subtraction problem, it's a little bit easier for me to identify the value of c. Since c is negative 2, we're gonna shift 2 units to the left. So we're gonna take this bad boy and shift it 2 units to the left. Wouldn't it be nice if we could actually move it? Too bad we don't have access to technology. Let me go ahead label these points that are highlighted. So this one is at 2, 1. This one is at 1, negative 1. And then this one is at negative 1, negative 1. And the other one is at negative 2, 1. So it'll just make it easier for me to do. So we're at negative 2, 1. Let me go ahead, locate that. And we set that the command is that we're going to go to left. So hopefully I know how to count. The next one is negative 1, negative 1. And we're going to go to left. 1, negative 1, go to left. 2, 1. So we go to left. Okay. And then we just connect our points. I'm going to do it like this so you guys can see it on the camera. And that kind of looks like this one. I took a screenshot. That's my low budget screenshot. And it kind of does look like, where am I? You should line up. So this is the graph of g of x. And this is the graph of g of, I think, what was it? G of x plus 2, which is the same as g of x minus negative 2, which we said we're going to left. And I think that's what we did. Okay, we have 2 more to wrap up this video. Okay, that's in my way. Problem B, we are asked to graph 3 times g of x. So let me just go ahead, write the time symbol. It's easier for me to highlight what's going on. So in this case, we're multiplying the function value by 3 because 3 is bigger than 1. Then we're going to have a vertical stretch by a factor of 3. So let me go ahead and write that down. Vertical stretch by a factor of 3. So remember, if c is bigger than 1, then we're stretching. If c is under 1, then we're shrinking. Okay, so let me go ahead take our sketch. So we're gonna multiply all the function values by 3. Okay, so if I'm at negative 2, 1, if you multiply the function value or y by 3, that will give us negative 2, 3. And the next one is negative 1, negative 1. Multiply the function value by 3, and that will give us negative 1, negative 3. Up on the list, we have 1, negative 1. Multiply the function value by 3, and that will give us 1, negative 3. For the grand finale, multiply the function value by 3, so that will give us 2, 3. So if we did this right, we wrote down our love note saying that we are multiplying the function by 3, so we should have a vertical stretch by a factor of 3. Yeah, if I had a pencil, I would just do it once because it's a little bit darker, but we work with what we can. So what did we do? We took this function and then stretched it 3 times by a factor of 3. And that kind of looks like we're stretching it. All right, so they thought this will never end, but finally, problem C. So in this case, we have the function and we have multiplying it by a negative. So this is going to be a reflection about some axis. So this is saying like we're going from positive y to negative y. So to go from positive y to negative y, we're going to reflect about the horizontal axis or the x-axis. Reflect about the x-axis. Okay, so let's go ahead, take those 4 points and reflect it about the x-axis. So the first one is negative 2, 1. So I am 1 unit away from the axis. So when we reflect or bounce it, we should be 1 unit away. Up next is negative 1, negative 1. Let's go ahead, highlight that. We're 1 unit away from the axis. So when we reflect, we should be 1 unit away as well, but on the other side. It's like taking a selfie, you know, like the pictures are the same, but it's just on the other side. 1, negative 1. So we reflect. We are 1 unit away from the axis. So we reflect and we should be 1 unit on the other side. Cool. For the grand finale, 2, 1. So 2, 1 is 1 unit away from the axis. So when we reflect, we should still be 1 unit away. So let's go ahead, connect these points. I did my best. So we had said that to graph negative g of x, we're going to take this bad boy and reflect it about the x-axis. So if I was able to physically turn it like this, oh, you can kind of see it. that wasn't planned.